Okay, in problem 3, we're asked to find the asymptotes and intercepts of this function, this rational function g of x. The first thing I want to do is see if I can factor the numerator and the denominator, because that might help me find some of this information. So it looks like the top can be factored in the traditional way, because here I see that 6 and 2 are multiples of 12, and they add up to 8. But I see it's a minus 8x, so I know we need to use the minus 6 and minus 2. So that takes care of the top. For the bottom here, I actually notice that there is a greatest common factor. All right, that's another little trick we can look at. So I see that this term here, 2x squared, and this term here, negative 32, are both have the factor of 2. So I can pull that out. And then what I'm left with is, in the inside of a parentheses, is x squared minus 16. Well, guess what? It looks like the difference of squares is making yet another appearance. Difference of squares. So we know from the last problem that the difference of squares can be rewritten as x minus whatever the square root of 16 is here, right, 4, and x plus 4. All right, so now we've got a factored form to look at and the traditional form to look at. And let's just go ahead and try and find some of these things. I'm going to use some abbreviations and go a little quicker in this problem. So hopefully you guys can follow along. VA, that's vertical asymptote. The way I find that is to see what makes the denominator 0. And here I have two options here. I've got two factors in the denominator right here. And x minus 4 can equal 0, or x plus 4 can equal 0. Well, on the top one, if I make the x value of 4, that satisfies that, or if it's negative 4. So I have two vertical asymptotes, one at x equals 4 and one at x equals negative 4. For the horizontal asymptote, I'm going to look at the degree of the numerator and denominator and see that they are the same degree. And so that means the horizontal asymptote is going to be the ratio of the leading coefficients. So here the ratio, we've got a 1 out front in the numerator, and we have a 2 out front in the denominator. So the ratio is 1/2. All right, that will lead us to a horizontal asymptote of y equals 1/2. What about the y-intercepts? Well, we just plug in 0. We're going to just plug in 0, and I'm going to do that using the traditional form here because I know that these three terms here will just go to 0 when I plug in 0. And so g of 0 will end up reducing to 12 over negative 32. And I see that both of these can be are factors of 4, so I'm going to reduce that fraction to 3 over negative 8, which means my y-intercept is at the point 0, negative 3/8. And lastly, my x-intercepts here, that's when the numerator goes to 0. Are there any values there? And we can look at the two factors in the numerator up here. We've got x minus 6 and x minus 2. Set those both equal to 0. And it looks like at the two values of x equals 6 and x equals 2, we have x-intercepts, which means our two coordinates are 6, 0 and 2, 0. Let's graph this on a calculator here and see what it looks like. Go ahead and pause it if you want to take the time to enter it now. Otherwise, I'm going to hit graph. And here's what our graph looks like. I see that we've done a great job finding a vertical asymptote at x equals negative 4. Here's another one that we found at x equals positive 4. There looks to be a horizontal asymptote at y equals 1/2. You see it crosses that asymptote in the middle, but the end behavior definitely tracks that horizontal asymptote that we found. Here's our y-intercept at 0, negative 3/8. And our two x-intercepts are at 2, 0 and at 6, 0. So that is looking great. Excellent job, you guys. One more problem today.